Okay, for do now number 6, we want to draw an acute angle and then construct the angle bisector and state a conclusion. Okay, on my iPad, I don't have a straight edge or a compass, and we know how good drawing a straight line worked for me in the last section, so let's see what happens here. I'll try to walk you through it though. And remember, an acute angle has degree measure is less than 90 degrees. So if I just go ahead and draw an acute angle, maybe there it is. And again, when you're going to bisect that angle, you can always go back and look at the videos from yesterday. You're going to put the eye of the compass right there, and you're going to draw an arc through that angle. Don't change the size of the arc or the size. Don't slide that compass out or shorter anymore. And then put the point there, and you're going to make an arc out here. And then put the point there and the same arc there. And then again, use a straight edge to connect this point with the point down there. And now there's your angle bisector. So to state your conclusion, if I call that angle 1 and angle 2, we can then say that angle 1 is congruent to angle 2. Okay, so section 1.6 is all about radicals. Okay, and when we're talking about radicals, the radical is the symbol itself, and the number that is underneath that radical sign is called a radicand. So the square root of 100 equals 10. Why? Because 10 times 10 gives you that 100 back. And is that the only answer? No. Okay, why not? Because if I took negative 10 and squared it, or if I took negative 10 and multiplied it by itself, a negative 10 times a negative 10 is a positive 100. So when you take the square root of a number, it can either be a positive or a negative. In general, we talk about something called the principal square root of a number. That's the positive. Principal starts with the letter P, and so it's positive. So in general, especially during this section, we are going to talk about the principal square roots, the positive square roots. Okay, perfect squares are a rational number that is multiplied by itself. So 1 squared, or 1 times 1, is 1. 2 squared, or 2 times 2, is 4. 3 squared, or 3 times 3, is 9, and so on. You can see that we went up to the number 12 on the screen here. 12 obviously isn't the last one. You can keep going after that, but in general, these are going to be the ones that probably help you out the most. So to simplify a radical, you want to find the biggest perfect square that divides evenly into the number. Okay, so for our first example, we want to write each in simplest radical form. So if I have radical 12, I want to go back to that list of radicals, and I want to find the biggest one that's a factor of 12. Well, if you just think about the factors of 12 in general for a second, you have 1 and 12, you have 4 and 3, and then you have 6 and 2. I'm not going to go through this on every single example, but just because this is the first one. So now when I look at that list of numbers, the 1, the 12, the 4, the 3, the 6, and the 2, there's only one of them that's even a perfect square. It's that 4. So that's the one that we have to use. There is no other perfect square in that list, so we're going to use 4 as the factor here. So we're going to have radical 4, and then I'm going to ask myself 4 times what would give me 12, and it would be 3. So I'm going to have radical 4 times radical 3. All you did was take that 12 and break it apart. You have not taken the square root of anything. That's why both those numbers are still underneath the Rudy house. Okay, but now since 4 is a perfect square, I can tell you what the square root of that number is. It's 2. So I'm going to go ahead and take the square root of 4. It's going to become 2, and then I'll bring down the radical 3. So 2 radical 3 is going to be my final answer there. Okay, again, notice that once you take the square root, it comes out of the Rudy house. If you do the square root of 4 in the calculator, again, you're going to get an answer of 2. It doesn't say radical 2, it says 2. So do not put that 2 underneath a square root symbol. For number 2, we have the square root of 48. So again, I want to sit and think about some numbers that go into 48. And again, I want the biggest one. So in this case, 4 is a factor of 48, but it's not the biggest one that goes into 48. It's not the biggest perfect square that's a factor of 48. The biggest perfect square that's a factor of 48 is going to be 16. So I'm just going to bring over that 4. And then I'm going to break down that radical 48 into radical 16. And if I do 48 divided by 16, I'm going to get an answer of 3. So it's going to be 4 times radical 16 times radical 3. Again, haven't taken the square root of anything. That's why the 16 and 3 are staying underneath those Rudy houses. Again, this first 4 is just going to come down. It is not underneath the Rudy house. Please do not try to take the square root of 4. It's just the number 4. However, the square root of 16, I know what that is. It's 4. And again, there's no symbol between the 4 and the radical 16. So what's going to happen is when there is no symbol, that's going to be multiplication. So that radical 16 now becomes that second 4 there. And then I'll bring down my radical 3. And the last thing I'll do is multiply 4 times 4, which is 16. So 16 radical 3 is going to be my final answer. Again, that 16 is not underneath a Rudy house. Please do not try to take the square root of it. Okay, next one for radical 98. Again, we're looking for the biggest perfect square. Sometimes, again, it's helpful to just write out the perfect squares. 1, 4, 9, 16, 25, 36. Have them somewhere next to you while you're doing your work, and then just start dividing 98 by that list until you find the one that does go into it. The perfect square that's a factor of 98 is going to be 49. So this is going to break down into radical 49 times radical 2. And again, the square root of 49 is 7. So 7 radical 2 will be my answer there. For number 4, I have 2 radical 72. So again, the goal is to find the biggest perfect square. That's a factor of 72. And in this case, that's going to be 36. So I'll bring over that 2, and I'll break that down into radical 36. And 36 goes into 72 2 times. So 2 times radical 36 times radical 2. Again, I know what the square root of 36 is. It's 6. Again, once you take the square root of 36, it is out of the Rudy house. So I'm going to have 2 times 6 times radical 2. And 6 times 2 is 12. So in the end, I'm going to have 12 radical 2 for my answer there. All right, so on our next slide here, we're going to start adding and subtracting radicals. So what we just did on the previous slide is going to come into play here. The very first thing that you're going to do is you're going to simplify all your terms like we just did on the last slide. And then for step 2, we're going to add or subtract the coefficients of the like radicals. We're going to add or subtract the numbers that come in front of the Rudy house. And then the radical stays the same. Again, think of it like when you add, think about when you add 2x plus 3x, the answer there is 5x. It does not become 5x squared. So when you're simplifying your radicals here, think of them like adding and subtracting like terms. So like radicals, that means you have to have the same exact number underneath the Rudy house. So 4 radical 3 and 2 radical 3, those two numbers are the same. So 4 plus 2 gives you that 6. And then again, we just bring over that radical 3. What is underneath that Rudy house does not change. It is like an x. So 4x plus 2x would be 6x. Therefore, this is 6 radical 3. And underneath that, just to give you an example of unlike radicals, I have a radical 5 and a radical 6. 5 and 6 are not the same number. I can't simplify either one of those radicals. There is no perfect square that's a factor of either one of them. So there's nothing that I can do with that problem. All right, so let's put that into play with these 3 problems here. Okay, so for my first example for number 5, I have 2 radical 7 plus 4 radical 63. When you have 2 radicals, it's always easier to start with a smaller radical. So the smaller radical here is 7. And if I look at 7, I can't find the perfect square that is a factor of 7. So that's going to end in its simplest form right now. That 2 radical 7, I cannot simplify any further. So I'm going to cheat. If I'm going to be able to combine these 2 radicals, that means that 7 is going to have to be a factor of 63. So if I take 63 and divide it by 7, I'm going to get an answer of 9. And 9 is the perfect square. So you can just kind of help yourself cheat a little bit there. So I'll just bring down that 2 radical 7, bring down the 4, and now again the perfect square that's a factor of 63 is going to be that 9. And then again we'll tack on the radical 7. Only thing that I can do next is take the square root of that 9. So again, I'll bring down the 2 radical 7, bring down that 4. The square root of 9 is 3, and tack on the radical 7. Again, order of operations, you must multiply before you add. So the next thing I'm going to do is multiply that 4 times 3. So again, we'll bring down that 2 radical 7. 4 times 3 is 12. So I have 2 radical 7 plus 12 radical 7. And again, the only thing that you're doing is adding the coefficients, 2 and 12. So 2 plus 12 is 14, and tack on the radical 7. Again, it's like 2x plus 12x. The x what does not change, neither does the radical 7. For number 6, I have 18 radical 5 minus 12 radical 5. And in this particular case, the radical 5 and the radical 5 are already the same. So I do have like radicals. So I can just straight do my subtraction right away. So I'm going to do 18 minus 12, which is 6. And tack on that radical 5. There's nothing further that I can do with that problem. Okay, so in number 7, I have 2 radical 32 and 3 radical 18. Again, for me, it is always easiest to deal with the smaller radical first. So let's break down the 3 radical 18 first. Perfect square, that's a factor of 18, is going to be 9. So this second piece is going to break down into 3 times radical 9 times radical 2. I'll bring down that plus sign. So eventually, if I'm going to end up being able to break down that radical 32, either the 9 or the 2 has to be a factor of 32. And this 9 isn't going to help me at all because that's going to be my perfect square that I'm going to take the square root of. So I'm going to look at this radical that I can't take the square root of. And now I'm going to look back at 32 and I'm going to ask myself, is 32 divisible by 2? And it is. 32 divided by 2 is going to give you an answer of 16. And again, 16 is a perfect square. So this is going to become 2 radical 16 times radical 2. So now the next thing that we'll do here is we're going to take the square root of our perfect squares there. So I'll take the square root of 16 and the square root of 9. So I'll bring down my 2. The square root of 16 is 4. Tack on that radical 2. Bring down the plus 3. The square root of 9 is 3. And bring down that radical 2. Again, order of operations, you must multiply before you add. So 4 times 2 is 8. Tack on that radical 2. You cannot actually multiply the 8 and the radical 2 together. They both have to be underneath the Rudy house for you to be able to multiply them back together. And since 8 isn't underneath the Rudy house, it's done. Again, if I had 8x, that would be 8 times x. You can't simplify that any further, just like you can't simplify this any further. And on the right, 3 times 3 is 9. So I have 9 radical 2. And 8 radical 2 plus 9 radical 2, when I add the coefficients, 8 plus 9 is 17. And then I'll tack on my radical 2. So 17 radical 2 is going to be my final answer there. Okay, so when you add or subtract radicals, again, you have to have the same exact number that's underneath that Rudy house. But now what we're going to see, if we're talking about multiplying and dividing radicals, you can multiply and divide radicals. Okay, so I'll show you what I mean by that in a second. So step number 1 is going to be to multiply or divide the coefficients, kind of like we just did in the last problems. But now for step 2, you can actually multiply or divide your radicands. Okay, and then your last step is going to be to simplify. Unlike addition and subtraction, you have to simplify first. That's the only way that you're going to be able to combine them. You do not need like radicals in order to divide or multiply. Do not simplify first. If you simplify first and then you multiply the numbers back together again, you might end up having to simplify a second time. So don't cause yourself extra work. Simplify last. So for number 8, we want to simplify 3 radical 16 times 2 radical 60. So again, step number 1 is to multiply the coefficients together. So 3 times 2 is 6. Okay, and now I'm going to multiply my radicands together. So radical 6 times radical 60. All I'm going to do is multiply 6 times 60 together. And that's going to give me an answer of 360. Again, I haven't taken the square root of anything. So again, Just going to stay underneath that square root symbol. So 6 radical 360 is my answer so far. But now I need to go and simplify that if I can. For me, something's jumping out about that radical 360 right away. Those first two numbers, 36, are a perfect square. Okay, so I'm pretty sure 36 is going to go in to 360. And if I do that on the calculator, I will see that you will get an answer of 10. So I'm going to bring down that 6, and then we'll break down that 360 to radical 36 times radical 10. Bring the 6 down. The square root of 36 is 6. Tack on that radical 10. And 6 times 6 will be 36. And tack on the radical 10. Again, please do not take the square root of that 36. It is not underneath a Rudy house. It is just the number 36. Okay. For number 9, I have radical 96 divided by radical 4. Again, do not simplify anything first. You're just going to go ahead and divide immediately. So if you go to your calculator and you do 96 divided by 4, you're going to get an answer of 24. Again, you have not taken the square root of anything yet. So that's a radical 24. Now that I've divided, now I need to simplify. So once again, I'm looking for the biggest perfect square. That's a factor of 24. And it is going to be radical 4. And if you do 24 divided by 4, you'll get an answer of 6. So it's going to simplify into 4 radical 6. And the number that's the perfect square there is that 4. The square root of 4 is 2, so I'll have 2 radical 6. Okay, and then lastly for number 10, I have 4 radical 30 times 6 radical 3. And again, the first thing that we'll do is multiply our 4 times 6. That'll give me an answer of 24. And radical 30 times a radical 3 is going to be a radical 90. Okay, another little trick again, just kind of like we did up in number 8 when I saw that the first two numbers of 360 were 36. And 36 is a perfect square. Look at here. The first number there is a 9. And 9 is perfect square. So let's see how many times 9 goes into 90. 90 divided by 9 would give me an answer of 10. I think we're going to be good to go there. So bring the 24 over. And I'll break this down into radical 9 times radical 10. The square root of 9 is 3, so I'm going to have 24 times 3 times radical 10. And 24 times 3 is going to give me 72, so I'll have 72 radical 10. And again, if I just kind of want to double check my work, I can ask myself again, do I have a perfect square that is a factor of 10? And I don't. Your perfect squares that are under 10 are only the number 3 squared, 9. 9 is the only perfect square, and 2 squared is 4. 4 and 9 are not factors of 10. So there is no way to break down that radical 10 any further. So that's your final answer. And just one last thing before I send you off to do stuff on your own. Every single time I've done a problem, when I break down the number, I'm always putting that perfect square first. Does it technically matter? Nope, because multiplication is commutative. So if I had written the radical 4 times radical 6 as radical 6 times radical 4, it's not a big deal. But just realize again in the next step that you would be taking the square root of 4, which is 2, and your answer is always going to come in this form. You always want the number in front of the Rudy house. So again, that would still become 2 radical 6. So just being a creature of habit, I always put the perfect square in the first Rudy house, and I always put the other number that I can't take the square root of in the second Rudy house. Again, it technically doesn't matter, but it just keeps your thoughts a little bit more organized, in my opinion.